principle of RC phase shift oscillator. We saw that the common emitter amplifier can produce 180-degree phase shift between its input signal and the output signal. Now, if we take the some signal from the output and given to the input of the amplifier, so it becomes negative type feedback. But the oscillator must be require positive feedback signal. So it is the essential condition for the oscillator. So that means we can say that the feedback signal should be in phase with input signal. So for that, if we take the feedback signal from the output, outputs, and it is given to the networks which provides 180-degree phase shift, and this signals is given to the input of this amplifier. So it becomes 180 plus 180 is equal to 360. That means you can say that your feedback signal is in phase with input signal, because 180-degree phase shift provided by this amplifier and 180-degree phase shift provided by the feedback networks. So this is the main important, and there are two methods of do this. First, by using RC networks. Now in this type networks, we are using RC networks which provide 60-degree phase shift. So to obtain the 180-degree phase shift by this network, three combination of R and C networks are used. Now similarly, by using Vein bridge. Now in these types of oscillators, we are using extra or additional amplifier stage which provides 180-degree phase difference. RC phase shift oscillator. Now here, this is the basic circuit of RC phase oscillator. Here Q is the NPN type transistor which act as a active devices for the oscillator. R1 and R2 are the voltage divider type resistor which provide proper bias to the base of this transistor Q. RC is the collector resistance which is connected in the collector circuit to obtain the outputs. RE is the emitter resistance which provides bias stabilization. CE is the bypass capacitor which provides ground level to the amplified AC signal by this amplifier. CI and CO is the coupling capacitor. Now here in this the three RC sections are used. Now the output signal is taken from this output of this amplifier, and it is given into the RC networks which provides the phase difference or phase displacement. Now this feedback signal passes through this three stage of this RC network, and each RC networks provide 60-degree phase displacement. So due to this three stage, it's provide 180-degree phase displacement between the input signal and the output signal. So the total phase displacement of this output of this oscillator is 180 degrees provided by the amplifier and 180 degrees provided by this RC phase shift network. So total phase difference is 0. That means there is no phase difference between input signal and the output signal, or you can also say that 0 phase difference between input signal and the output signal. Thus the positive feedback is obtained in this oscillator. Here the at which frequency the oscillation the RC phase shifts provide 180-degree phase displacement is called oscillator frequency, and which is represented by F0 is equal to 1 upon 2 pi RC under root 2 into n, where n is the number of stage, r is the resistance, the value of resistance used in this RC phase network. C is the value of capacitor C used in RC network. Here one most important thing, the value of these three resistance are same, and as well as the value of capacitors, it is also remains same. And now the at oscillator frequency, the feedback factor beta is equal to 1 upon 29. So to start the oscillations, the loop gain AB should be greater than 1. So put the value of beta in this equation, A into 1 upon 29. So should be greater than 1, and A is greater than 29. So you can say that the value of this gain is greater than 29. That is, if the value of this gain is less than 29, continuous oscillations will not occur. Next, the advantages of this RC phase shift oscillator. It provides higher stability, and no inductor is required in these circuits. In these circuits only resistance and capacitors are required, which reduce the weight of the circuit and as well as the cost of the circuit. For less frequency can be obtained. Disadvantages of this RC phase shift oscillator: the magnitude of the output waveform is less. The frequency cannot be changed. That means it is fixed. Third, it is difficult to start the oscillation due to the very low feedback signal.